Introduction: A whisper in the cosmic dark. In the vast silence of the cosmos, where time stretches into eons and distances cannot be measured in simple steps, the story of every star begins as nothing more than dust. Not the dust we know in the corners of our daily lives, but the ethereal remains of ancient stars scattered like golden ashes across interstellar space. This cosmic dust drifts endlessly, suspended in the void, illuminated only by the faint glow of distant galaxies. It is here, in this quiet expanse, that the seeds of new light are sown. Stars, the radiant beacons that decorate the heavens, are not born in an instant. Their beginnings are subtle, slow, almost imperceptible to the hurried eye of humanity. They emerge from a delicate dance of physics and time, woven from the most fundamental forces of nature. Gravity, ever patient, begins to gather particles together, while invisible whispers of energy shape the path ahead. What seems lifeless and silent is, in truth, a hidden symphony preparing to rise. The tale of Stardust is also the tale of us. Every atom of oxygen in our breath, every spark of iron in our blood, was once forged in the furnace of an ancient star that long ago burned brightly, collapsed, and shared its essence with the universe. To trace the journey of Stardust is to trace our own ancestry, written not in books, but in light and elemental dust scattered across the galaxies. When we look up at the night sky, we are not only observing distant fires, we are gazing at our origin. Nebulae, vast and delicate as veils, are the cradles of these transformations. They stretch for light years, painting the heavens in shades of rose and violet, sculpted by winds of radiation and gravity's unseen hand. To enter a nebula is to wander into a nursery of stars, where dust thickens into clouds and clouds fold into knots, each knot holding the promise of brilliance. For millions of years, unseen to any eye, a star takes shape here, wrapped in a cocoon of dust and shadow. Science offers us the language to describe this birth. Temperatures in these clouds may fall to just 10 degrees above absolute zero, yet within their darkness lies the power to ignite thermonuclear fire. Gravitational collapse compresses the gas, and as pressure rises, so does heat. What was once cold dust begins to stir, glowing faintly, marking the first heartbeat of a protostar. But beyond the technical, there is poetry. To imagine a star's birth is to imagine a transformation that bridges silence and song, darkness and light. It is a journey from fragility to power, from invisibility to brilliance. And though the process spans millions of years, in the stillness of contemplation, we can walk beside it. This audiobook is an invitation to such a journey. Together, we will drift through the stages of stellar formation, from the quiet drifting of dust to the blazing arrival of new suns. Each chapter will unfold like a step in a cosmic pilgrimage, filled with both scientific clarity and the serenity of wonder. We will explore the mechanics of collapse, the secrets of protostars, the elegance of hydrostatic balance, and the radiant language of starlight itself. Alongside the science, we will linger in the awe these processes inspire, for knowledge and beauty are never far apart in the cosmos. Close your eyes and imagine the vast, cold dark between the stars. Imagine particles drifting silently, as if the universe itself is breathing in slow motion. Now, imagine gravity, gentle but insistent, pulling these fragments together, sculpting them, preparing them for transformation. This is not only the story of how stars emerge, It is the story of how the universe renews itself endlessly through cycles of birth and light. In this stillness, let us begin.
Chapter 1: The Origins of Cosmic Dust. Before a star is born, another must first end its life. This is the paradox of the cosmos. Creation and destruction are inseparably intertwined, and from the death of giants comes the fragile seed of new light. Cosmic dust, the building block of future stars, is not an eternal presence, but the aftermath of ancient celestial dramas. It is the residue of explosions, the ashes of colossal furnaces that once blazed across the night. Every star is a factory of elements. In its core, hydrogen fuses into helium, and as time advances, heavier elements like carbon, oxygen, and iron emerge. For stars much larger than our Sun, this process escalates until their cores can no longer sustain the weight of fusion. In those final moments, gravity wins the battle, and the star collapses inward with immense violence. Then, in an instant, it rebounds outward in a titanic explosion, a supernova. The brilliance of a supernova outshines entire galaxies for a brief time, but its true gift lies not in the spectacle of light. It lies in what it leaves behind. The violent shock waves rip atoms apart and scatter them across space. Out of this storm emerge grains of cosmic dust, tiny fragments composed of silicates, carbon, and metals. They are minuscule, often less than a micrometer across, but they carry within them the heritage of stellar alchemy. These grains drift outward, propelled into the void, becoming travelers of the interstellar medium. Some may linger near their place of birth, forming glowing remnants like the Crab Nebula, a tapestry of colors woven from dust and gas. Others travel farther, spreading invisibly through the arms of galaxies. Though fragile, these grains endure for millions of years, awaiting the chance to gather again. Not all cosmic dust is born from supernovae. Smaller stars, those closer in size to our Sun, end their lives in gentler but equally transformative ways. As they exhaust their fuel, they swell into red giants, shedding their outer layers in luminous waves. What remains is a dense white dwarf, but surrounding it lingers a halo of expelled material, a planetary nebula, glowing faintly like a cosmic lantern. Within those shells of gas, dust forms, seeded by molecules that condense as the star's outer atmosphere cools. Together, these two processes, the explosive deaths of massive stars and the graceful fading of smaller ones, fill the universe with dust. Without it, galaxies would be sterile, devoid of the ingredients necessary for planets, for oceans, for life. Dust is not an inconvenience of the cosmos, it is the very fabric from which the future is stitched. Yet cosmic dust is more than material substance. It is also a veil and a painter. It absorbs starlight, dimming the brilliance of distant suns, and scatters photons, painting galaxies with mysterious shadows. Astronomers must peer through this haze to uncover the secrets of stellar nurseries, and in doing so, they discover something profound. Dust does not merely obscure, it also protects. Within dense clouds of dust, fragile molecules like water and organic compounds can form, shielded from harsh radiation. In this way, dust is both the cloak and the womb of creation. To think of its scale is humbling. A single grain of cosmic dust, invisible to the naked eye, can drift across interstellar space for millions of years before joining a molecular cloud. Trillions of such grains, born from countless stellar deaths, form the canvas on which new stars will shine. Each particle is a tiny archive preserving the memory of the star that forged it, carrying whispers of temperatures, pressures, and elemental symphonies that once blazed at the heart of suns. If you could hold a mote of cosmic dust in your hand, you would be touching the aftermath of eternity. Within its structure would lie atoms of carbon that might one day form the core of a planet, silicates that could harden into rock, iron that could flow through the veins of a living being. It is a reminder that the universe wastes nothing. What ends in fire always begins anew. The universe is not empty. It breathes in silence, scattering ashes of stars through its vastness, gathering them again, igniting them once more. Cosmic dust is its breath, its whisper, its promise of renewal. And in the stillness of this truth lies the beginning of every star.
Chapter 2. Gravity's Gentle Embrace. In the stillness of the universe, where particles drift endlessly and silence stretches across light years, there exists a quiet architect. It does not shout, nor does it shine, yet it shapes galaxies, binds worlds, and gives birth to stars. That architect is gravity, a force both invisible and irresistible, pulling on every atom, guiding the cosmos in its eternal dance. After dust has been scattered into space by dying stars, it wanders aimlessly as if waiting for purpose. Each grain seems insignificant, a solitary traveler in an infinite sea. Yet gravity, with infinite patience, begins to weave threads between them. The pull is delicate at first, almost imperceptible. But over thousands and millions of years, it gathers these fragments, coaxing them into a greater whole. What was once chaos slowly becomes order. This process gives rise to the vast interstellar clouds that populate galaxies. These clouds, called molecular clouds, are the silent arenas where stars will one day be born. Composed primarily of hydrogen molecules laced with helium and traces of carbon, oxygen, and other elements, they stretch for hundreds of light years. And though they may appear dark and empty to our eyes, within them lies a richness of matter, bound together by gravity's embrace. Inside these immense clouds, not all regions are equal. Some are slightly denser than others, with particles more closely packed, and it is here that gravity works most effectively. A small increase in density attracts more material, which increases the pull further, creating a cycle of accumulation. Like ripples gathering into waves, gravity amplifies what is already present, sculpting the seeds of future stars. It is a process of balance and tension. While gravity pulls inward, there are opposing forces at work. The gas within the clouds exerts pressure, resisting collapse, and magnetic fields thread through the dust, adding stability. Turbulence stirs the gas, creating eddies and currents. Yet gravity persists, slow but unyielding, bending these competing influences until regions of instability emerge. These are the knots in the cosmic fabric, the places where stars will take form. From a scientific perspective, this is the gene's instability, a threshold where a region of a cloud becomes massive and dense enough that gravity overwhelms internal pressure. Once this threshold is crossed, collapse becomes inevitable. The cloud contracts, and the atoms within it draw closer, colliding more frequently, warming ever so slightly. What was once a drifting cloud of gas is now the womb of a star. But beyond equations and thresholds lies poetry. To imagine gravity's work is to imagine the universe breathing inward,
gathering its scattered breath, preparing to ignite life anew. It is a silent calling, a gentle but insistent tug that refuses to let the cosmos remain still. Without this force, dust would drift forever, stars would never be born, and the night sky would remain dark and empty. Consider for a moment the time scale. While human lives span decades or centuries, the slow work of gravity spans millions of years. What we call collapse, in truth, is an unhurried drift toward destiny. From our perspective, it is unimaginable slowness. From the perspective of the universe, it is the natural rhythm of existence. Even as we study gravity with mathematics and observation, there remains mystery in its essence. We know it as the curvature of space-time, as Einstein described. Yet to the heart, it feels like something more. A thread binding everything that exists, connecting dust to stars, stars to galaxies, and galaxies to us. It is the cosmic embrace from which nothing can escape, and yet, without it, nothing could begin. So the story of stars moves forward. Dust once scattered now gathers. Clouds once diffuse now coalesce. In this quiet and relentless act of gathering, the first steps of creation are taken. The universe whispers, and gravity listens, pulling the fragments of eternity closer until the silence gives way to light.
Chapter 3. Nebulae, Cradles of Light. Across the canvas of the universe, there exist vast regions of color and shadow, delicate yet immense, painted by particles so fine they seem almost like whispers in the cosmic dark. These are the nebulae, the cradles of light. They are not merely clouds of gas and dust, but nurseries where new stars are patiently sculpted. To look upon them is to see both beauty and promise, for within their veils lies the secret of stellar birth. A nebula may stretch for hundreds of light years, its filaments weaving intricate patterns across the void. To the human eye, many appear as faint smudges, but through the lens of a telescope, they blossom into breathtaking forms: pink petals of hydrogen gas, blue wisps of scattered starlight, and dark rivers of dust cutting through the glow. These colors are more than decoration. They are the language of chemistry and energy, a code written in light that tells us of the processes unfolding within. At the heart of a nebula lies hydrogen, the most abundant element in the cosmos. Mixed with helium and traces of heavier elements, this gas forms the raw material of stars. But it is not simply the presence of matter that makes a nebula special. It is the conditions. Nebula are shaped by gravity, turbulence, and radiation, all of which weave together to create regions dense enough to collapse. When gravity gathers the gas and dust into knots, these knots ignite the slow process of transformation that will one day produce the brilliance of a newborn star. There are many kinds of nebulae, each telling its own story in the great cycle of creation. Emission nebulae glow with vibrant light, their atoms energized by the fierce radiation of nearby young stars. Reflection nebulae shimmer faintly like ghosts, scattering the starlight that passes through them. Dark nebulae, in contrast, appear as voids, blocking the stars behind them. Yet within their shadows, some of the most promising seeds of starlight are hidden. Each type plays a role in the cosmic balance, contributing to the theater of birth. Among the most famous examples is the Orion Nebula, a vast nursery visible even to the naked eye on a clear winter night.
Within its glowing folds, hundreds of stars are in the process of forming, surrounded by disks of material that may one day grow into planets. To gaze at Orion is to look into a stellar nursery just 1,300 light-years away, a place where creation is not abstract but vividly present. The Carina Nebula, with its towering pillars of dust, offers another glimpse. Its massive clouds sculpted by the winds of stars already born, shaping the next generation of light. What makes nebulae remarkable is their duality. They are places of both concealment and revelation. From afar, they enchant us with their colors and forms, but within, they hide processes invisible to human eyes. Cold, dense regions collapse in silence, while radiation carves patterns of brilliance across their surfaces. They are both guardians and midwives, shielding fragile beginnings while broadcasting their grandeur across the galaxy. From a scientific perspective, nebulae demonstrate the delicate balance of forces required for star formation. Too much turbulence and the gas disperses. Too much radiation and the fragile molecules are destroyed. Yet within these immense clouds, small sanctuaries exist where gravity can prevail, where atoms can gather, where dust can weave itself into the first structures of a star. Beyond the equations, there is wonder. To imagine a nebula is to imagine the universe as an artist, layering strokes of light and shadow across infinite space. Each filament is a brushstroke, each glowing region a signature of creation at work. Nebulae remind us that the universe is not static. It is alive with process, unfolding patiently, like a symphony played over millions of years. And so the nebula stands as the cradle of light, a vast, silent womb where dust and gas scattered by the deaths of stars are drawn together once again. It is here that the universe rehearses its eternal cycle, taking what was lost and transforming it into something new. To drift within a nebula is to drift within a promise that out of darkness, light will always return.
Chapter 4: Molecular Clouds, Silent Architects. Deep within the arms of galaxies, hidden from the brilliance of starlight, lie immense shadows that stretch for light years. They are not empty voids, though they may appear so. They are the densest and coldest reservoirs of matter in the universe, molecular clouds, the silent architects of stars. Within their frigid depths, where temperatures sink to just a few degrees above absolute zero, the most delicate and powerful alchemy begins. A molecular cloud is, in essence, a vast congregation of gas and dust. Unlike the more diffuse regions of interstellar space, these clouds are dense enough for atoms to join together into molecules. Hydrogen, the simplest and most abundant element, binds into pairs, forming H2. Alongside it, carbon monoxide, water vapor, and more complex organic molecules take shape, protected by the cloud's coldness and shadow. Without this shelter, radiation from surrounding stars would tear them apart. But here, in the stillness of molecular clouds, chemistry flourishes. They are colossal in scale, spanning tens to hundreds of light years, containing the mass of thousands or even millions of suns. And yet, despite their immensity, their densities are astonishingly low by earthly standards. A single cubic centimeter of air on Earth contains trillions of molecules, while a similar volume within a molecular cloud may hold only a few hundred. But in the vastness of interstellar space, this is enough. Enough
for gravity to weave its patient work, enough for dust and molecules to gather into clumps that will one day blaze as stars. These clouds are not uniform. They are turbulent, shaped by shocks from nearby supernovae, stellar winds, and galactic tides. Within them, some regions remain diffuse and drifting, while others become knots of higher density. It is in these knots, shielded by thick dust, that the earliest stages of star formation occur. Astronomers call them dense cores, hidden sanctuaries where gravity begins its slow collapse, compressing matter toward the birth of a protostar. From a scientific perspective, molecular clouds are both laboratories and archives. The molecules within them absorb and emit radiation at specific wavelengths, especially in the radio spectrum. By listening to these signals with powerful radio telescopes, astronomers can trace the movements of gas, measure its temperature, and even identify the presence of complex organic compounds, molecules that are the raw ingredients for life. Thus, molecular clouds are not only star factories, they are also chemical workshops, preserving the recipes of creation. One of the most famous is the Orion Molecular Cloud Complex, a vast region stretching hundreds of light-years, within which lies the Orion Nebula. Here, astronomers have identified thousands of young stars, disks of dust where planets may form, and intricate filaments of gas collapsing into new generations of suns. It is both a nursery and a museum, holding clues to how stars like our Sun and planetary systems like our own once began. But beyond the science, there is a quiet poetry in imagining these clouds. They are places of darkness, invisible to the naked eye, yet they carry the promise of brilliance. They remind us that creation often begins in silence, that the most profound transformations are hidden, waiting patiently in the shadows. A molecular cloud is like a vast cosmic womb, where the future of galaxies is conceived, though no light betrays the miracle inside. To drift within such a cloud would be to enter a realm of obscurity. Stars beyond would vanish behind veils of dust. The temperature would fall close to the edge of nothingness, and molecules would huddle together for warmth in the dark. And yet, in this seeming stillness, the universe prepares its most luminous gifts. Gravity tightens its embrace. Atoms draw nearer. Pressure rises. The invisible architecture takes shape, slowly but inevitably, until the silence will one day be broken by light. Molecular clouds are the silent architects of the cosmos. They take the ashes of dead stars, preserve them in cold shadows, and patiently assemble them into new suns. They are reminders that the universe does not hurry, that time itself is the canvas on which creation paints. And in their quiet vastness, they whisper the truth that even in the darkest places, the future of light is always being written.
Chapter 5. From Dust to Clumps, Seeds of Stars. The vastness of a molecular cloud may seem endless, its particles drifting in silence, held together by gravity's patient hand. Yet even within this immensity, the universe is never uniform. Subtle differences emerge, tiny ripples in density, faint fluctuations in temperature that become the very catalysts of creation. From these irregularities, the first seeds of stars are sown. In the stillness of interstellar clouds, certain regions are slightly richer in matter than others. At first, the difference is so small it seems inconsequential. a whisper lost in a cosmic sea. But gravity is a tireless sculptor. The denser the region, the stronger its pull. More dust and gas are drawn inward, amplifying the disparity. What was once a minor imbalance becomes a growing knot, a clump forming in the quiet shadows of the cloud. These clumps are the nuclei of future stars. Known as dense cores, they are pockets of gas and dust where gravity has overcome the delicate balance of pressure and turbulence. Inside them, particles collide more frequently. The temperature begins to rise, and the invisible journey toward collapse begins. It is within these cores that the slow alchemy of transformation takes its first decisive step. The process is guided by the principles of physics, yet it feels almost poetic. A cloud that seemed formless suddenly acquires structure, as if the universe itself is sketching with invisible hands. Ripples turn into waves, and waves gather into knots. These knots, though fragile, carry within them the potential for brilliance. They are the first chapters in the biography of a star. From a scientific perspective, this process is described by instability. In particular, the gene's instability defines the point at which gravity overwhelms pressure in a region of gas. Once crossed, collapse is inevitable. The clump contracts, its particles spiraling inward, releasing heat as potential energy transforms into motion. Slowly, the hidden core gathers strength, becoming hotter and denser, preparing for the birth of a protostar. But these clumps do not emerge in isolation. The turbulent nature of molecular clouds ensures that hundreds, sometimes thousands of such seeds may form simultaneously. In vast nurseries like the Orion molecular cloud, stars are born not as solitary wanderers, but as siblings, their destinies intertwined in clusters. They grow together, shaping one another's evolution through gravity and radiation, reminding us that even in the cosmos, creation is often a communal act. Astronomers, peering into these regions with infrared and radio telescopes, can observe the signatures of these hidden cores. They detect the faint glow of dust warmed by collapse, the subtle shifts in molecular lines that reveal motion. Though invisible to the naked eye, these observations confirm what the poetry of imagination suggests. Within the dark, stars are already taking shape. Beyond the science, there is wonder in the fragility of this stage. A clump of gas, only slightly denser than its surroundings, contains within it the possibility of light that may one day travel across the universe, illuminating distant worlds. It is a reminder of how little is needed for creation to begin. Just a fluctuation, a ripple, a small departure from uniformity. From such small beginnings arise suns, planets, and the potential for life itself. To imagine drifting into one of these clumps is to enter a realm of gathering silence. Dust swirls softly, pulled inward by gravity's embrace. The airless void presses close. Yet within the core, warmth begins to bloom. Slowly, invisibly, the future takes root. The clump tightens, densifies, and holds within it the spark of a destiny yet unseen. Thus, from dust to clumps, the seeds of stars are planted. It is a stage defined not by brilliance, but by promise, not by light, but by the anticipation of light to come. The universe, in its quiet patience, demonstrates once more that even the smallest irregularities, the faintest fluctuations, can grow into sources of radiant wonder.
Chapter 6. The Hidden Heat Within.
As the dense cores of molecular clouds continue their slow contraction, something extraordinary begins to unfold. The dust and gas, once cold and drifting, now grow closer, particles colliding with increasing frequency. Though invisible to the eye, a subtle warmth emerges, an energy hidden deep within, the first heartbeat of a star yet to shine. This is thermal energy, born of compression. As gravity pulls matter inward, potential energy is transformed into kinetic energy. Atoms vibrate, jostle, and collide, generating heat that gradually rises within the heart of the contracting core. At first, this warmth is slight, barely a whisper in the cosmic silence, but it is a signal that collapse is advancing, that the once inert dust is stirring with life. The surrounding molecular cloud remains frigid, mere degrees above absolute zero. Yet within the core, temperatures climb steadily. This hidden heat is a delicate balancing act. It pushes back against gravity's relentless inward pull, slowing the collapse just enough to allow structure to form. It is as though the universe itself is pausing, holding its breath, nurturing the transformation with care and patience. As the core grows denser, the energy becomes more concentrated. Molecules begin to vibrate with increasing intensity. Dust grains radiate faintly, and subtle chemical reactions may commence. Water, carbon monoxide, and other compounds respond to the rising temperature, preparing the environment for the complex alchemy that will eventually sustain a newborn star. This internal warmth, though invisible and silent, is the spark of potential, the first step toward the brilliance that will one day pierce the darkness. From a scientific perspective, the rise of thermal energy is fundamental. It governs the rate of collapse, influences the formation of rotating disks around the protocore, and sets the stage for nuclear fusion. Without this gradual warming, the core might fragment prematurely, producing smaller, less stable structures. With it, the protostar gains the conditions needed to ignite the processes that will transform dust into fire. Yet beyond physics, there is profound poetry here. In the heart of a cloud, shielded from the harsh glare of distant stars, matter stirs in patient anticipation. Invisible vibrations ripple through the gas, carrying the silent promise of light yet to come. The core becomes a hidden sun, a heart beating slowly in the dark, a secret of creation preserved until the moment of awakening. To imagine this process is to imagine time itself stretching, measured in millennia rather than hours or years. The heat rises imperceptibly, unnoticed except for the patient forces of the universe. And in that slow, deliberate emergence, the universe whispers its eternal truth, that even in silence, transformation is underway, and even in darkness, warmth is being born. The hidden heat within a protostar is more than energy. It is the first sigh of life, the precursor to radiance, the invisible herald of a new sun. From it, all light and warmth in the surrounding cosmos will eventually flow. It is here, in the quiet crucible of a contracting core, that the universe prepares to turn stardust into brilliance.
Chapter 7. The Birth of Protostars. From the dense, cold cores of molecular clouds, a new chapter begins. The hidden heat that gradually arose from compression now reaches a threshold, marking the emergence of a protostar. It is a delicate, luminous entity, neither fully a star nor mere gas. It is the universe in transition,
a being in which gravity and pressure engage in an intricate, eternal dance. The protostar is born from the tug-of-war between opposing forces. Gravity, relentless and patient, pulls inward, compressing gas and dust into tighter confines. Pressure, born of rising thermal energy, pushes outward, resisting collapse. The result is a fragile balance, a suspended state in which the protostar slowly contracts, heating as it does so, yet remaining stable enough to avoid immediate explosion or dispersion. Within this young object, matter spirals inward, drawn by gravity, yet redirected by rotation. A circumstellar disk forms, a flattened ring of gas and dust that will one day give rise to planets and other celestial bodies. Magnetic fields thread through the spinning material, shaping jets of matter that shoot outward into space. In this environment, the protostar is both nurturing and turbulent, serene in potential, yet dynamic in form. Temperatures within the protostar continue to rise, reaching thousands of degrees. The innermost regions become dense and hot enough that hydrogen molecules begin to dissociate, a crucial step on the path to fusion. Yet even as the core struggles to ignite nuclear fire, the outer layers remain relatively cool, bathed in the soft, dark cloak of the molecular cloud. The light we might imagine is subdued, hidden, a promise rather than a display. From a scientific perspective, this stage is critical. It sets the mass, rotation, and composition of the star. The protostar may oscillate, contracting and expanding slightly as internal pressure adjusts to gravitational pull. Jets of material and winds expel excess angular momentum, allowing the core to continue its contraction. Every motion, every subtle shift is a delicate negotiation that will determine whether the star matures into a stable main sequence star or fragments into smaller companions. Yet beyond equations and observation, there is beauty in this struggle. The protostar embodies tension and harmony, patience and anticipation. It reminds us that creation is seldom instantaneous. It is a process of compromise and resilience. Within the swirling cloud of dust and gas, something remarkable is taking shape, a luminous promise emerging from the silent darkness. If we could observe a protostar up close, we would witness soft glows through dense dust, faint thermal emissions in infrared light, and the gentle shaping of circumstellar disks. We would sense motion, though imperceptible to human senses, as gravity and pressure negotiate the boundaries of existence. It is a delicate, almost meditative process, a cosmic breathing in which matter tightens, heats, and begins to glow. The birth of a protostar is not a sudden event, but a quiet transformation. It is a journey from diffuse matter to structured brilliance, from inertia to dynamism, from potential to manifestation. In every protostar lies the echo of countless stellar deaths, the whispers of dust that once drifted aimlessly, now gathered into coherence by the patient hands of gravity. And so, in the depths of molecular clouds, hidden from the naked eye, protostars emerge. They are the first spark of radiance, the nascent hearts of future suns, and the eternal testament that even in silence and darkness, the universe creates relentlessly. From these tender beginnings, the cosmos will soon be illuminated by the light of new stars.
Chapter 8. Disks of Creation. Encircling the tender glow of a protostar lies a structure of quiet purpose and profound potential, a protoplanetary disk. These disks of creation are flattened rings of gas and dust, spiraling gently around the young star, silently shaping the destiny of worlds yet to come. Within them lies the blueprint of entire solar systems, the unseen architects of planets, moons, and asteroids. The formation of such a disk begins naturally from the conservation of angular momentum. As the protostar gathers mass, the surrounding gas and dust, influenced by rotation, cannot fall directly inward. Instead, it spreads into a broad, thin disk, orbiting in graceful symmetry. To the human eye, it might seem static, but in reality, it is a dynamic, ever-changing environment where collisions, condensation, and accretion slowly sculpt matter into larger structures. Temperature gradients mark the disk. Close to the star, heat from the nascent sun vaporizes volatile compounds, creating a region dominated by silicates and metals. Farther away, where the embrace of the star's warmth is gentler, ices can condense, allowing water, ammonia, and methane to coalesce into solid particles. These gradients dictate the composition and eventual arrangement of planets, moons, and asteroids. Each orbiting particle is a building block, a fragment of potentiality suspended in time. Within the disk, particles collide softly at first, sticking together like cosmic dust bunnies. Over millennia, these clumps grow larger, forming planetesimals, the seeds of planets. Gravitational interactions guide their paths, sometimes scattering them, sometimes drawing them closer to aggregation. It is a meticulous choreography, a slow dance of matter and force that will eventually yield entire planetary systems. Observations in infrared and millimeter wavelengths reveal the intricate structures of these disks. Gaps and rings, once invisible, now appear as signatures of early planet formation, as nascent worlds carve paths through the surrounding material. Spiral arms twist gently, waves of density sweeping outward, carrying gas and dust like currents across a cosmic sea. Every detail tells a story of creation in motion, of systems in gestation, and of the patient artistry of gravity and physics. Beyond the science, there is a quiet poetry in these disks. They are bridges between chaos and order, between scattered dust and structured worlds. In their silent rotation, one can imagine the eventual birth of rocky planets, gas giants, and icy comets. They are laboratories of potential, where time is measured in thousands and millions of years, yet every moment counts in shaping the architecture of the future. These disks are also reflective of the universe's continuity. The dust and gas within them carry the elemental heritage of countless generations of stars. Carbon, oxygen, iron, and silicon, forged in ancient stellar cores and scattered by supernovae, now gather around a new sun. In this way, each protoplanetary disk is a cosmic relay, a continuation of creation, passing the baton of matter from one stellar generation to the next. Imagine drifting above a disk of creation. The protostar glows at the center, warmth radiating outward, while countless particles orbit silently, tracing elliptical paths. Minute collisions spark faint heat, waves of density ripple through the gas, and subtle magnetic fields guide motion. Time stretches, imperceptible to human perception, yet within these motions lies the genesis of worlds that may one day harbor oceans, mountains, and perhaps even life. In essence, these disks of creation are both cradle and workshop. They nurture the growth of planets, regulate the distribution of material, and preserve the memory of ancient stars. From their delicate spirals, the cosmos writes its next chapter, transforming dust and gas into structured systems of wonder and complexity. They remind us that the universe is patient, meticulous, and infinitely creative, turning the quietest motions into the grandest outcomes. And so, around each protostar, these disks spin silently, holding the promise of planetary birth, echoing the eternal rhythm of the cosmos, and carrying forward the legacy of Stardust into new realms of light and life.
Chapter 9. The First Glimmers of Light. At the heart of the collapsing core, where dust and gas have gathered and temperatures have climbed, a remarkable transformation takes place. The protostar, once a hidden mass of swirling matter, begins to ignite. The first glimmers of light pierce the darkness, faint yet undeniable, marking the birth of a true star. This light emerges from nuclear fusion, the alchemy that powers the stars. Deep in the core, hydrogen atoms collide with increasing frequency, their kinetic energy overcoming the natural repulsion between nuclei. In a flash of subatomic choreography, hydrogen fuses into helium, releasing vast amounts of energy. The reaction is tiny in scale at first, a mere flicker compared to the blazing sun we see in the sky. Yet it is the beginning of brilliance that will last for millions or even billions of years. The onset of fusion transforms the protostar. The energy generated in the core pushes outward, counterbalancing gravity's relentless pull. The delicate tug-of-war that has maintained the protostar's structure stabilizes into a dynamic equilibrium. Gravity still pulls inward, shaping the star's mass, while fusion pressure pushes outward, maintaining its form. The star begins to glow steadily, its internal fire now visible through the surrounding cloud of dust and gas. From the perspective of an observer, this first light is subtle. The nascent star emits primarily in infrared, invisible to the naked eye, yet detectable by specialized telescopes. The surrounding dust glows faintly as it absorbs and re-radiates energy, casting a soft halo around the newborn star. It is a delicate illumination, a whisper of the power that will soon radiate across light years. The first glimmers of light are also the harbingers of change for the surrounding protoplanetary disk. Radiation from the young star begins to heat the disk, influencing the chemistry and dynamics of forming planets. Jets of matter may burst outward from the poles, sculpting cavities in the cloud and signaling the star's growing strength. Every flicker of light and stream of particles is part of the star's emergence into the cosmic theater. Scientifically, this phase is known as the pre-main sequence stage. The star continues to contract slowly, its core temperature rising until hydrogen fusion reaches a steady state. Once equilibrium is fully achieved, the star enters the main sequence, a period of stability that can last for billions of years. But even before this point, the light from fusion defines the star's presence in the galaxy, announcing that creation has succeeded. Beyond the physics, there is profound poetry in this moment. In the silence of space, where darkness once reigned, a small, persistent spark begins to shine. It is the first audible whisper in the language of light, the universe declaring that potential has become reality. Dust that drifted aimlessly for eons now orbits a luminous heart, and the cycles of creation continue with renewed purpose. To imagine witnessing the first glimmers of a star is to imagine time stretching and condensing simultaneously. Millennia of slow accumulation culminate in the spark of fusion. Light, energy, and heat emerge from the hidden interior, transforming a once invisible mass into a beacon of radiance. It is a reminder that even in the vastest darkness, life and light find a way to begin. Thus, the protostar graduates into stardom. Its first light may be faint, but it carries the promise of countless generations of photons, illuminating dust clouds, guiding planetary formation, and marking the continuation of the cosmic cycle. From this quiet, fiery birth, the universe gains a new sun, a new center of warmth, and a new storyteller in the endless saga of creation.
Chapter 10: The Balancing Act. Hydrostatic Equilibrium. With the first glimmers of nuclear fusion illuminating the core, the young star faces a subtle but crucial challenge. it must find balance, a delicate equilibrium between the inward pull of gravity and the outward push of radiation and gas pressure. This harmony, known as hydrostatic equilibrium, is the foundation of stellar stability and the key to a star's enduring life. Gravity, relentless and invisible, continues to pull matter inward, shaping the star's dense core and surrounding layers. Simultaneously, fusion reactions generate energy in the core, producing photons that push outward, transferring momentum to the surrounding gas. These opposing forces must achieve perfect balance. Too much inward pull would collapse the star. Too much outward pressure would cause it to expand and lose mass. The star's very existence hinges on this elegant cosmic tug-of-war. The process is gradual and subtle, measured in terms of thousands or millions of years. The core temperature stabilizes as fusion produces just enough energy to counteract gravity. Layers of gas above the core adjust continuously, contracting or expanding ever so slightly to maintain equilibrium. It is as if the star breathes slowly, adjusting its internal motions, finding a rhythm between contraction and expansion that will persist for eons. From a physical perspective, hydrostatic equilibrium governs a star's size, luminosity, and lifespan. A star too massive for its fusion rate may struggle to balance, leading to rapid evolution or instability. Conversely, smaller stars achieve equilibrium more easily, sustaining their light for billions of years. The interplay of mass, energy, and pressure shapes not only the star itself, but also the environment around it, including any emerging planetary systems. Observationally, the balance manifests as stability in brightness and size. A star in hydrostatic equilibrium emits a nearly constant stream of radiation, bathing its surroundings in predictable light and warmth. The protoplanetary disk, still swirling with gas and dust, responds to this stability, allowing planets to form along orderly orbits. In this way, the star's equilibrium is not merely an internal feature, it orchestrates the wider cosmic neighborhood. Yet beyond the scientific details, there is a meditative beauty in this balance. The star, born from chaos and collapse, now achieves harmony, a luminous meditation in the darkness of space. Its light is neither frantic nor dim. It is steady, patient, and enduring. Hydrostatic equilibrium embodies the quiet wisdom of the cosmos, demonstrating that creation thrives not only in force, but also in careful adjustment, in negotiation, and in restraint. Imagine floating above a young star in this phase. You would witness a glowing sphere of gas, radiating steadily while currents of plasma circulate silently, carrying energy outward. The star maintains its form effortlessly, as if guided by unseen hands, a perfect balance of energy and matter. Its internal motions are invisible, yet they preserve the star's very existence, ensuring that it will shine for millions or billions of years to come. In essence, hydrostatic equilibrium is a cosmic harmony, a fundamental principle that allows stars to live long, illuminating their corners of the galaxy and nurturing potential planets. It is the calm after the storm of formation, the steady rhythm that follows the violent birth of light, and a testament to the universe's ability to craft order from chaos. Thus, the young star stands as a beacon of stability. Gravity and pressure entwined in eternal balance, it radiates warmth and light, setting the stage for planetary evolution, galactic interactions, and the ongoing story of cosmic creation. In this quiet act of equilibrium, the universe teaches us that enduring brilliance arises from measured harmony, patience, and careful balance.
Chapter 11. The Language of Light. Spectral signatures. Once a star has found its balance, radiating steadily through the darkness, it begins to tell a story. This story is written not in words, but in light. Each photon that escapes carries secrets of the star's composition, temperature, and history. Scientists have learned to read this language, known as spectral signatures, unlocking the hidden truths of the cosmos. When a star emits light, it is not uniform. Atoms within the star absorb and emit photons at specific energies, producing a unique pattern of lines across the spectrum. Hydrogen, helium, carbon, iron. Each element leaves its distinct mark, like a fingerprint embedded in the stellar glow. By analyzing these lines, astronomers can determine the chemical composition of a star with astonishing precision, even from light that has traveled thousands of light years to reach Earth. Spectral analysis reveals more than just composition. The width, shape, and shift of these lines provide insights into temperature, pressure, magnetic fields, and motion. A slight red shift indicates a star moving away. A blue shift signals approach. Broadened lines may hint at rapid rotation or turbulent internal motions. Through careful observation, scientists transform light into a detailed map of a star's physical and chemical characteristics. This language of light is a cosmic dialogue, connecting distant stars to our instruments and minds. Telescopes equipped with spectrographs can separate starlight into its constituent wavelengths, revealing intricate patterns invisible to the naked eye. It is through this delicate method that astronomers understand the life cycles of stars, the abundance of elements, and even the processes that govern fusion deep in stellar cores. Beyond technical analysis, there is a poetic beauty to spectral signatures. Each star speaks in its own timbre, a quiet melody of photons that carries tales of origin, transformation, and eventual fate. By listening carefully, we witness the echoes of nucleosynthesis, the slow fusion of atoms that has been underway for millions or billions of years. Light becomes not only illumination, but also memory and narrative, preserving the history of matter across cosmic time. Spectral signatures also reveal the presence of phenomena invisible in ordinary light. Magnetic activity, stellar flares, and convection currents imprint subtle variations in the spectral lines. Even circumstellar material, from dust disks to planetary atmospheres, leaves faint traces detectable in high-resolution spectra. Through these delicate markers, the young star's environment is revealed, from the swirling disks of creation to the nascent planets forming within. For the observer, the act of decoding stellar light is a quiet meditation. Each line, each absorption or emission feature represents a balance of energy, motion, and chemistry. In the stillness of a telescope dome, astronomers translate photons into knowledge, listening to the universe as it speaks in the language of light. It is a bridge between human curiosity and cosmic phenomena, a reminder that understanding is often rooted in patience, observation, and attention to detail. Spectral signatures also connect generations of stars. By comparing the elemental abundances of different stars, astronomers trace the enrichment of the galaxy, following the journey of elements forged in ancient supernovae and recycled into new stellar generations. Each photon becomes a messenger, linking the past, present, and future of cosmic matter in a continuous, luminous chain. In essence, the light of a star is more than illumination. It is a story, a record, and a guide. It carries the fingerprints of its internal processes, the imprints of its environment, and the echoes of its lineage.
By deciphering this language, we gain access to the intimate workings of the universe, understanding the chemical and physical poetry that underlies every star. Thus, spectral signatures transform starlight into narrative. Each observation is an act of quiet listening, revealing composition, motion, and history. The universe communicates in photons, and in learning its language, we witness the cosmic symphony that unfolds silently across the vast reaches of space.
Chapter 12. Stellar Nurseries Across the Universe. Across the vast canvas of the cosmos, regions of creation glow with ethereal beauty. These stellar nurseries, vast clouds of gas and dust, are the birthplaces of stars, the sacred gardens where light is born. Among the most famous are the Orion Nebula and the Carina Nebula, each a testament to the universe's artistry and cosmic patience. The Orion Nebula, a mere 1,344 light-years away, is a luminous expanse where young stars emerge amidst swirling gas. Infrared and visible light reveal the delicate filaments of dust, glowing with heat, while nascent stars peek through, their presence marked by gentle radiation and subtle motion. The nebula's colors, often captured in breathtaking images, reflect the energy of ultraviolet light, exciting hydrogen atoms, painting the clouds in soft reds, greens, and blues. Carina, farther and more massive, hosts the legendary Eta Carinae, a star of extraordinary mass and energy. Within each nebula, the process of star formation unfolds at scale, showcasing clusters of young stars forming simultaneously. Dust lanes wind like ribbons, dense knots harbor protostars, and stellar winds carve vast cavities. Each structure, though shaped by physical forces, possesses an aesthetic harmony that feels almost intentional. These nurseries are more than visual marvels, they are laboratories of cosmic evolution. Observations reveal how stars of varying masses form in proximity, how their radiation shapes nearby gas, and how early planetary systems begin to shape within circumstellar disks. Turbulence, magnetic fields, and shock waves play crucial roles, orchestrating a symphony of matter that transforms chaos into order. For the observer, there is a quiet meditation in tracing these regions. Beyond scientific data, one feels the universe breathing, expanding and contracting, creating light in silence. Every filament, every glimmer is a reminder of the patient rhythm of cosmic creation. The nursery is alive in its subtle motions, yet serene, a space where time flows differently, measured not in days but in millennia. The poetic beauty of stellar nurseries lies in their duality. They are both violent and gentle, chaotic yet structured. Supernova remnants and strong winds coexist with soft condensation and coalescence, demonstrating that creation thrives amidst tension. In witnessing these nurseries, one glimpses the intimate processes that give rise to stars, planets, and the potential for life itself. Ultimately, stellar nurseries connect us to the broader cosmos. They remind us that every atom in our bodies was once part of such a cloud, scattered by ancient stellar deaths and gathered anew. Each star born today carries the legacy of countless ancestors, echoing across the universe and inviting contemplation of our own cosmic origins.
Chapter 13. Time as a Sculptor. The Evolution of Young Stars. Once stars emerge from their natal clouds, time begins its careful work, shaping them subtly yet inexorably. Young stars evolve, their temperatures, sizes, and luminosities changing as they journey toward the main sequence, a state of balance and enduring light. In this slow evolution,
The cosmos acts as a patient sculptor, molding stellar form over millions of years. During this pre-main sequence phase, stars contract gradually under gravity, while their cores heat steadily. Thermal pressure rises, fusion ignites, and the delicate dance of energy transfer begins. Convection currents stir interiors, magnetic fields thread plasma, and rotation guides angular momentum. Even minor differences in mass or composition dictate divergent paths, illustrating the universe's sensitivity to initial conditions. Some stars, more massive than the Sun, evolve rapidly, burning brighter and hotter. Others, smaller and cooler, take longer, glowing softly yet persistently. Variations in rotation, chemical composition, and accretion rates create a diversity of stellar behaviors, reminding us that creation is never uniform. Time sculpts each star uniquely, transforming a clump of gas into a structured, radiant body. Meanwhile, interactions with the surrounding environment shape the young star further. Stellar winds clear residual gas, sculpt disks, and influence planet formation. Nearby stars may gravitationally perturb one another, introducing chaos into the otherwise orderly process. The evolution of young stars is thus a dialogue between internal physics and external forces, a subtle negotiation over millions of years. Observation of clusters like the Pleiades or NGC 2264 provides insight into these early stages. Astronomers detect subtle changes in luminosity, spectral lines, and rotational velocity, tracing how stars settle into equilibrium. Each observation offers a snapshot of ongoing transformation, capturing the interplay between time, gravity, and fusion in a delicate cosmic choreography. Poetically, this phase illustrates the patience of the universe. Stars mature quietly, often unnoticed by human eyes, yet their evolution sets the stage for planetary formation, chemical enrichment, and the broader cycles of life and death in galaxies. Time, in this sense, is both artist and mentor, shaping the cosmos with care and precision. Ultimately, observing the evolution of young stars is a meditation on change itself. It demonstrates that transformation is gradual, deliberate, and interconnected. Every star carries the signature of time's sculpting hand, and within their light we witness the subtle, unhurried poetry of cosmic growth.
Chapter 14. Echoes of Creation. What Young Stars Teach Us. The study of young stars offers profound lessons about the universe and our place within it. Each star's birth echoes ancient processes, tracing cycles of matter, energy, and time that have unfolded for billions of years. Observing these fledgling lights teaches us about the continuity of creation, the inevitability of change, and the intricate balance between order and chaos. Young stars illuminate the pathways of nucleosynthesis. Within their cores, hydrogen fuses into helium, laying the foundation for future elements. These processes reveal the lineage of atoms, connecting present matter to the ashes of long-dead stars. Carbon, oxygen, nitrogen, all essential for life, are forged in stellar furnaces, reminding us that we are made of the echoes of previous cosmic generations. Additionally, young stars teach patience. Their evolution is measured in millions of years, a scale far beyond human lifetimes. Their gradual maturation demonstrates that significant change requires time, persistence, and delicate balance.
In watching their slow transformation, we gain perspective on the temporal vastness of the universe and the rhythms that govern its growth. The interplay of light, gravity, and matter also convey lessons about interconnectedness. Disks around protostars evolve into planets. Clusters of stars interact gravitationally, and stellar winds shape surrounding clouds. Each process is linked, revealing a universe where individual actions ripple outward, influencing distant regions and future generations of stars. Furthermore, young stars illustrate resilience. They form amidst turbulence, collisions, and competing forces, yet emerge luminous and structured. This resilience mirrors broader cosmic principles. Creation often arises through struggle, adaptation, and the delicate negotiation of competing influences. In essence, studying young stars is an act of listening. Each photon, spectral line, and disk pattern speaks of history, transformation, and potential. By tuning in to these cosmic signals, we glimpse the mechanisms of life, death, and renewal on a universal scale. They remind us that creation is cyclical, eternal, and profoundly interconnected.
Chapter 15, The Poetry of Becoming. At the close of our journey through the birth and early life of stars, one truth emerges. We are connected to the cosmos in ways both intimate and infinite. The stars, born from dust and shaped by time, carry within them the materials that formed planets, oceans, and even life itself. In observing their creation, we see reflections of our own origin. The poetry of becoming is woven into every phase of stellar life, from scattered dust to clumps, from hidden heat to luminous light. Stars embody transformation. They remind us that growth is gradual, patience is essential, and even the smallest beginnings can lead to radiant outcomes. Each star's journey mirrors the human experience, a passage from potential to realization, from obscurity to illumination. Our atoms were once stardust, drifting through ancient nebulae before coalescing into planets, oceans, and bodies capable of thought and wonder. By contemplating young stars, we recognize this shared ancestry, the profound continuity linking us to the heavens. The universe, in its cycles of birth and death, invites reflection on impermanence, resilience, and the beauty inherent in change. Stars also teach humility and awe. Their processes unfold on timescales beyond human comprehension, yet they shape worlds, chemistry, and life itself. In their quiet, patient brilliance, we perceive a harmony that transcends the noise of everyday life, a reminder that existence is part of something vast and ordered, yet ever-changing. Ultimately, the poetry of becoming is the celebration of emergence. From dust to light, from potential to reality, from chaos to harmony, the cosmos narrates its story through stars. And in listening, watching, and imagining, we participate in that story, understanding that our own lives are threads in the grand tapestry of the universe, a tapestry spun from the same stardust, warmed by the same hidden heat, and illuminated by the same first glimmers of light.
Conclusion. Returning to the starlight. As our journey through the cosmos draws to a close, we pause to reflect on the incredible transformation we have witnessed. From scattered grains of stardust to radiant young stars, the universe unfolds in quiet, patient motion. Gravity gathers, heat rises, and light emerges, each step a testament to the intricate balance of forces that shape creation. The stars we have followed are more than distant points of light.
They are living laboratories, silent storytellers, and mirrors of our own origins. Within their cores, matter is forged and recycled, echoing through space and time, connecting generations of cosmic events. Hydrogen becomes helium, dust becomes planets, and the processes that give birth to stars also give rise to the building blocks of life itself. Observing this transformation is a lesson in patience and resilience. Stars evolve on scales far beyond human perception, yet their journey from dust to light teach us about timing, harmony, and the delicate interplay of forces. In their cycles of birth, maturation, and eventual death, we see the rhythm of the universe reflected, a cadence that resonates even in the quietest corners of our minds. The universe invites us to listen, to imagine, and to marvel. Each protostar, each protoplanetary disk, and each luminous main sequence star carries the legacy of countless generations of cosmic matter. In contemplating their formation, we recognize that we too are composed of stardust, sharing an intimate connection with the vast expanse that stretches beyond our eyes. As we return from this voyage, the lessons of the stars remain. Creation is patient, transformation is gradual, and beauty arises in balance. The light that now fills the cosmos is the same light that has traveled billions of years to reach us, carrying whispers of ancient processes and the promise of future generations. And so, in the quiet glow of your imagination, let the stars remind you, we are part of the universe that is constantly creating, constantly evolving, and constantly illuminating the darkness. From dust to light, from potential to brilliance, the story of the stars is, in many ways, also our own, a reminder that even in silence and stillness, transformation is always underway.